Let's talk about stratified random sampling. And we need to think about quota sampling because the process of choosing the stratifications for stratified random sampling is the same process that we use to create the quotas for quota sampling. The big difference is that with quota sampling, once we determine that we need 30 males and 40 females, then we do a convenient sample to get our 30 males and 40 females, or however I said that. If we're using stratified random sampling, we find those same quotas, but then we do a random sample of all the females and choose the first 30, do a random sample of all the males and choose the first 40, if that was my example. Let's do a specific example so the numbers will all be correct. First, we have data for Eastern New Mexico University, and you can print those data tables or just refer to them on my math lab if you want for these two examples. So to do that, you go to course materials. So I'm just going to show you how to get there. Go to course materials, click there, and then we want to come down to data. Click there, and then you'll see that we have two data tables. The first one is NMU students by major, and it looks like this, and you can see that we have the major, the College of Business, College of Education and Technology, College of Fine Arts, College of Liberal Arts and Sciences, and then non-college specific. So we have all those groupings, and within a grouping you can see that we have broken the students down by undergraduate and graduate, and then we have totals. Within each undergraduate and graduate, we also have males and females and then total students. So we have a whole bunch of data here about all the students, and this was from fall 2013, and it is from the fall 2013 census, so looking at every student. Now we have another data table you can see here, and that is the fall 13 enrollment as of census day again, and this is giving us the different categories of students, so freshmen, sophomores, juniors, seniors, etc. And then it's telling you the ethnicities for the undergraduates and then for the graduate students. So we have them by male and female as well, so you can tell from this chart, if I wanted to know how many Hispanic female students were attending the fall 2013, then I can look Hispanic column, female down here, and I can see the undergraduate total is 920, and then that makes me wonder what's the graduate total, and I see that's at the bottom of the chart. So females down here 263, so I have 920, and I have 263. So I know I have 1,183 Hispanic female students. So I can do that for any categories, and if I think about the undergraduate separately from the graduate, or I can look at the total here, and it should show us in the Hispanic column 1,183 females, so I could have just found that as the total on this chart. And I can also see where I have males and females totals for part-time, full-time students. I have a bunch of different categories. It's almost too much information, but these are the tables we are going to use modeling what you would do in the real world when you wanted to create a sample that was representative of your student body based on, in the first example, will be gender. So let's take a look at that. So using the table, I want to ensure that a sample of 65 students from the student population of, how many students did we have all together? Let's see if we can find that. Students by major. That should show the total number of students. So we'll pop that up, and I'm looking for total number of students. Ooh, I can see totals here. Let's see what they're broken into: undergraduate and graduate, and then the combined undergraduate and graduate together. So I'll have males over here females over here, males and females, and I wanted to know how many male students I had. So 2,000 plus 324. So that's going to give me, total number of students altogether. So we want to ensure that a sample of 65 students from ENMU's student population of blank. So we need to know how many students we have at Eastern. So if I come to, this is the number of students by major, and I can see it has male, female, male, female. Down here at the bottom it shows the totals, all students together, 5,855. So I can put that onto my sheet. We have 5,855 students, and that's both male and females together, undergraduates and graduates together. And I want to have, for my sample of 65, I want to have the same proportions as in my full population. And so I know I have 5,855 students. Some number of them are male, some number are female. So if I find the percents, then I can use those to find a representative sample. So let's look back on the sheet. In this case, we have how many male and how many female students. And the total we know still is 55. And if I'm looking at male students, let's pop that back to the front again. This is the university totals, and it's the males here for undergraduate and graduate. So let's slide down. So this will be males and this will be males. This is undergraduate and graduate. And then that's going to give me this number for females, because we'll need that as well. So I'll just do the 2,000 plus 324, and that one I can do in my head. So I have 24 male students, and female, it looks like I can still see those. I have 2572, so 2572 plus 959, and so I get 3531. 3,531 females. So out of the total students, 5855. Now I'm looking at one characteristic here of my population, one characteristic, and that's gender. And in a minute I'll look at two characteristics and we'll look at how that is different. But so for the one characteristic, I want to find the percent of males in my population. So I have 24 out of 5855, and that's just a division. So 24 divided by 5855. And you can see I get 0.3969, and what I'm looking for is a percent, so I will multiply by 100 by moving my decimal 2 places to the right, and that will give me 39.69, and the next digit is a 2, so it'll stay 39.69%. Now for females, I have 3531 out of 5855, and so I'll type that in, 3531 divided by 5855, and so I have 60.307, so it'll turn to 60.31 because that 7 follows, so it's going to make me bump the 0 up to a 1. So there I have 39.69, 60.31. Generally use 2 decimal places when you're calculating these percents, and then at the end you'll round. But in the interim, it works out better if you do it that way, because then your percents total 100. You're less likely to lose some of the people you need. So 39.69 plus, I want to double check this, 60.31, and it totals exactly 100%. If we get really close, we're happy, and this one's exact, so we're happy. Then I know now the number of males I have in my sample is 39 0.69%. The number of females is 60.31%, and I have to take that of my sample size. So my sample size up here I saw was 65 students, so of my sample size. So then we're thinking again, I do that 0.3969, change it back to a decimal, times 65, and I get 25.7985, so 25.8, and we're going to change that to 26 males. And we have to do that. We have to round the numbers because we can't interview a fraction of a person. So next one, 60.31, so 0.6031 times that sample size of 65, and I get 39.20, so 39.2 people, and remember we can't have 0.2 of a person, so we'll just interview 39 females. Okay, so my sample at this point, since I'm doing a stratified random sample, now what I will do is take all of the males for Eastern New Mexico University and list them out, do a random number selection like I did for the random sampling, so I'll use random.org, and I'm going to take the first 26 males off of that list. So it's going to give me a list of numbers. I'll put them back and compare them to my original list and choose the ones that came up on random.org as the first 26. Then I will do the same thing for the females. So at this point I've created my category or my quota or my stratification, and now I go to a randomly ordered list that matches the total numbers I have for my population of females, and I'll take the randomly ordered list, choose the first 39 numbers from that list, and match them back up to my original list, and those will be my sample for the females. So the big difference here between a quota and a stratified sample is what you do after you choose your quota or your stratification. This process that we did to find the number of males and the number of females to talk to should look very similar to what we did for quotas. But the big difference with stratified random sampling is what you do afterwards. So once we choose the quotas, again, we will list out every person, every male, and give them a number, come up with a randomly ordered list from random.org, and then we will use the first 26 numbers off of that randomly ordered list of numbers. Same thing for the females then.